Cool. I think that's running. I think that's running. Yeah. Cool. All right. Hi, everyone. I was told there's going to be 4 people turn up. Where's lighting? Cool. Oh yeah. I know you were looking for a WebGL talk. You're going to get a GraphQL talk instead. Okay. I like just before I start, I just want to say thanks to Adam for filling us in, because it's something I'm pretty passionate about. I did it at my own company, and yeah, it's great to be able to actually put it out there. So, right. So I am Phil Ostler. I'm a Yorkshireman. Grew up in Cornwall and educated in Wales. The only person I know in that room is that man who had to go to university with me. And you'll find me either hanging out in reggae bars in Berlin or on the beach in Cornwall generally when I'm not coding. So, a little bit of my background. So, after university, I went to the Met Office. I worked there for 5 years. I did Flex and ActionScript there, and worked on their premium products. So, I did a lot of weather analysis and stuff like that. If you've ever taken off or landed from Gatwick, a piece of my software has made sure your plane can actually land. So that's very scary. Now I work over at Queen Square at Forge Rock. So we build OpenAM, which is sort of the reincarnation of OpenSSO, which is a single sign-on server. It's a very old product, 15 years old, Java side. The JavaScript side is about 3 years old, so I spend most of my days working in Backbone, handlebars and stuff like that. Most of the days, anyway. So that's me. And you came here to talk about React. So I don't know, I thought I'd just show of hands. Who's actually played with any React? Or yeah, pretty good now, okay. Is anyone using it in production? Yeah. Okay. There's a bit of a cool, that's great, cool. I'm no React expert, I'm not going to say I'm a React expert. I love it, I've been playing with it a lot. We don't use it in production at Forge Rock. But hopefully, if you haven't used it at all, you'll get interested in it and you want to play with it. And also, you hopefully get interested in something like GraphQL Relay. So React's been out there for a few years now. And very recently, Facebook also thought they'd try and tackle the problem of how to get data into your application. So React's all about componentizing your application, brand new way of developing almost in some ways. And GraphQL is a new way to actually speak to servers, and Relay sits in the middle, so you can get your server to talk to your client, your React application. So we'll go for this. This is all really cutting edge stuff at the moment. This is so GraphQL is a technical preview at the moment. It is alpha quality. I wouldn't use it in production. Who was using it in production? Oh, React, not the other one. Yeah, okay. So we've got some demos today of all this, all working. So you'll be able to see it benefit and go out there and play with it. I've put all this on GitHub as well. So all these examples, you can go off and have a look. So play with them, install them, great. So, first of all, what is React? So, simply, it's a library for building views. It's the V in MVC. It's not opinionated about anything else you use. It's not a framework as such. It just sits in that small layer, and it doesn't, it's not the kitchen sink. It's not everything in the world, which is great. It's originally came out of Facebook and Instagram, and they open sourced that in 2013. They've been using it for a few years. They use it in production. So if you go onto Instagram's page right now, that is React and one massive React application, which is awesome. And there's other people now using it. So if you go onto Airbnb, they're now using React as well. So it's spreading, people are using it, and in only a couple of years, it's got really good penetration, which is awesome. So why should you care, though? I know it's Facebook and Instagram, but do you care? Oh, well, someone knows. Well, we should care because Facebook kind of a different beast. I don't usually use notes, but I didn't use notes last time. It was fine. Facebook want what we will want. We want to work at velocity. We want to build really good products. We want to create new features faster. We want more stability from our products. So they want what we all want, ID. But they also work at massive scale. They've got 1.5 billion active users. And they encounter things we never encounter, like, just the pure scale and what the problems they have to deal with and the cross-platform problems. We don't come across these. A lot of us don't. But they do, and so we can actually benefit from their scale and their resources and the people working on that to actually take advantage of the fact that they have come and go far enough to discover possibly a new way of development or a slicker way that we can all take advantage of. And of course, we want to build better UIs anyway, so we should listen, see any possible new options out there. So let's take a step back and look at what we do today. So this is really broad. I'm very aware everyone does very different things, but I'm just trying to go on a very broad angle. So someone comes to me, build me a component. So for the very basic building blocks, we need a few things. We need some kind of view controller, and I do Backbone, so you'd have something like this. You need somewhere to sit your logic in. Everyone knows this. You have to put your events in there, you have to have some sort of model syncing. You've got a render function, but Backbone, for instance, doesn't care how you render it, so you're going to have to fill that in. And then you've got all your other logic. So that's one part of the puzzle, that's the JS side. Then you're actually going to have to get your thing rendered on page. So we're on two things now. So this is a handlebars template. Everyone knows these, very simple. There's many different versions, types, syntaxes, etc. and so forth. Pick your one and render your page. That's it. Of course, we need one final thing. We need styling as well. So this is a typical less template, less file. So yeah, that's right. You need that to layer on top, and you've got your component. So we've got in the end. So we got our component now. But we had to use three technologies together. That's three technologies we had to write. That's three technologies we had to actually maintain in the future as well, because we've written all this and it's not going to stay static. It never does. It's three things to keep in our head. If I actually go in and actually modify something, you've got to look at the CSS and worked out how that's working with the template, where it's applied. Okay, right. The JavaScript's got something else that adds the class and removes the class. You've got to keep all of that in your head. And we all know these things aren't simple. These things get hugely complicated and they extend each other. And this is a lot to keep in your head. If you just want to do things simple, it can get quite complicated. This is where you end up in this thing where you look over your colleague's shoulder and they've got 20 tabs open because they're having to do 20 things at once. And also sharing. Can I share that easily? Maybe. Depends how strict you are about how you encapsulate things. But probably not as easy as if I had one file or one place with my component. So that becomes hard because I can't share things around between other colleagues or in the same organisation. So I think you get the message now where this is going. Three things. So the question is it a separation of concerns or a separation of technologies? So I think a lot of people think it may be a separation of concerns, but it is a separation of technologies, in my opinion, and Facebook's opinion. This is how they view it. They want to minimise the amount of split work you have to do. And the result of all this that we've talked about is it's harder to write, you have to write boilerplate, it's harder to maintain. As I said, you've got to keep it all in your head. And that makes it a fragile and slow process. You break things. Ideally, we've all got tests that do full code coverage. You touch something and it breaks and you know about it, but not all of us do, and not everything's tested. And of course, the final thing, which is the point I keep coming back to, is that it breaks your mental model. You want to work on one thing, not working on 20. So, what's React's approach? So React looks at it from a completely different angle. They encourage encapsulation of the components, so that styling, that logic, that templating gets sucked into one place, one component effectively. And this works with some other stuff that goes on in Magic in React called the virtual DOM, which is like a ghost DOM. So nothing actually gets directly put onto the DOM immediately. It has an interim process, and I'll show you that in a moment. It's also got unidirectional data flow, so data goes in, but there's no bidirectional binding like you get in some frameworks. So you'll see that in a moment as well, how the data goes in and it flows out the other side. And also the other big thing about React is this is how we do markup. You do JSX markup, which is a way of embedding your HTML into your actual JavaScript files. Now, they do this in their backend systems for ages. They put things and they transpile it, and they've brought this to React as well, so you can have everything effectively in line in the same file. So, let's have a quick look. Let's have a look at a real basic demo. They'll get more advanced than this. It's not with this demo. So, let's have a look at that. So all this has been built in Webpack at the moment. So Nice, easy. Hello! Hello, React. So let's have a quick look, see what's going on here. So in the DOM, we've got some stuff that looks a bit weird. You can actually get a plugin for React, and you can see in better detail exactly what's happening. So it looks like we've got some sort of component on page. It's called hello. That's great. And we're passing in some properties. Let's go look at the code, see how this works. Oh, sorry. Yeah, I'll move to this and. I can't do the left-hand side. I'll try and do the other bit in a moment. So this is a really simple app. It's just an index page. Nothing fancy going on there. It's built in Webpack and then it's served up. So this is like the most basic, obviously the most basic app you can write. This is using a slightly new. So there's two versions of React actually throughout this presentation. There is 0.13, which is the stable version, and the 0.14, which is the real edge version. That's the version I'm using to demonstrate some of the more advanced GraphQL features later on. So up here we're importing React. We're importing React DOM. So there's a separation of where you render to as well. You don't have to render to a browser immediately. And we're importing some component. And then we do use this syntax. So we just say render onto the page our component, please, into this ID. And we're going to pass some React thingy. Now this looks great now, but when we actually put this through the transpiler, it actually comes out as this. So it allows you to not have to write this. You can write this if you want to. Compile this. It allows you to have nice syntax when you're actually writing your markup. And the actual JSX itself, it's very simple. So all it is, this is just a simple thing that just, everything's got a render function effectively. And that returns just some JSX. And this obviously is getting compiled down underneath this, so it's just method calls as well. So this.props are effectively constructor arguments, these things that get passed in, and these things magically appear, and you can use them anywhere. So this is ridiculously simple. You don't want to see this. Move on to something else. So how does this work in something slightly more complex? So let's look at something more stateful, and we can see how the render flow happens then. Let's get that one fired up. So this is just oh, there we go. Can you see that on the left-hand side? So it's just seconds ticking up on a component. So once again, we can see in here we've got some kind of component, and as you can see, it's updating its state. We see it in real time. Its state being updated. So in React, you've got effectively two things going on. You've got props, which are the initial state that you pass in, constructor arguments, if you will. And then you've got the state, which are internal state machine stuff you want to keep track of. And this is what we're doing here. We're keeping track of the seconds. And it's just updating and rendering to the page, as you can see. So how does this work underneath the hood? So same thing again. It's all Webpack. Exactly the same here. Just passing in our timer component. So we're doing something a little bit different here. We've got all these little functions that allow us to do stuff. So we have to set up an initial state. So obviously we're creating a new React class here. We get an initial state. We're setting our seconds to 0. So this is basically default initial state. And then we've got these functions here, which allow you to determine what happens when the component mounts and demounts from the DOM tree. So we're doing something very simple. We're just setting up an interval that we tick on every second, and we call something else down here. And when we unmount, we turn it off. Simple as. Now, what happens down here is we're setting the state. So on the tick, we're actually setting some state up. And this is the magic function. It's one of the magic functions. We call that will trigger a render. So we're just passing in additional seconds. That's going to trigger that automatically. That's going to trigger the entire system off. And that happens every time you set new state in React. It's going to do all that automatically behind the scenes. And the great thing is the diffing, the virtual DOM that we were talking about earlier, it's going to do all that automatically and find the most efficient way to render that onto the page. So that's basically what it said. So every time there's a state change, we render, but not to the DOM. It calls that render function that outputs a bunch of HTML, output of some description. And what it does then, it just takes that and does a diff with this virtual DOM. And the idea is that you only update the DOM when you really, really need to make it quicker. You don't, not continuously hitting the DOM and updating, because it's a slow operation, it's costly. And the point is that it only replaces what's changed. And the idea that this is faster. Now, I'm aware that you can do this, you can do things in Angular and stuff like that to enhance performance to make this more optimum. But I'm trying to talk about out-of-the-box things here, the sort of the way it's designed to be powerful and performant for out of the box. So if I try and explain, if we have a mythical theme framework called Angles, so we're trying to do something very, very simple. So we've got a list of cities on the left, and afterwards we want to get to this list of cities, so that's great. How many DOM updates are we going to have to do in Angles to get there? And how many DOM updates are we going to have to do in React to get there? Well, we're looking at 3 and 2. And the reason is because I'm trying to illustrate exactly what React's trying to do, is that Angles is going to look at that, and it's going to go, okay, right, we've got this list, that isn't there anymore. I'm going to remove that, take that away. And now I've got 2 new items as well, so I'm going to add that in, and I'm going to add that in. That's 3 operations. React doesn't do that because of the way it diffs the DOM and it looks at the things that have changed. It's going to replace that rather than removing and adding. And then it just adds another element on, so it's saving writes to the DOM each time. And that's where its speed comes from, this speed out of the box. Of course, we can get there close with other things, but the idea is it's trying to do this out of the box in a more native and easy to use way. So that's just sort of the real basics of React. But the big wins, I think, are the fact that it encourages clean encapsulated components. And the idea that you can then take those components and share them. So those things I had earlier, I could take that and give it to you and it would work fine. There's also other things in there that, question. So things like how do we do styling, for instance? Well, you can use CSS and stuff like that, but you can also do all your styles in line, which you'll see later, which some people go at. A lot of people go at. I'm not very opinionated. I like the fact that everything's embedded almost. And you can do fancy things. So you could have your styles in line, and then you can say what can be overridden and what can't be overridden, because you're passing it in your interface when you first construct that component. So there's lots of things we can do here that we couldn't do before. And that, of course, that aids usability, because then we can go and say, hey, great, okay, right, we can build a component that we can make more modular and granular, and we can pass it out and use it and upgrade it. The other great thing about React is the fact we don't need a browser. So I hinted that earlier in the fact that there's a React and React DOM. So that's been separated out recently, that you can render onto the DOM, but you don't have to render onto the DOM. You can build your own library to render onto whatever you want, which is great. You could get to render out to ASCII if you wanted to. And the great thing is, of course, you can create isomorphic JavaScript applications so that you can render on the server in Node. And it's not the nicest and easiest thing to do still, but it's doable, and it's a lot more doable than it has been in the past. And then there's the other side of React, which is the native side that they've been pushing. Now, if anyone got iOS and they've been using the Messenger app in iOS, I think it's the Messenger app. No, the sort of the group messenger app. You've already used this, and you've already used GraphQL as well, as far as I understand. They've got React Native, which means on iOS at the moment, Android coming soon, that you can do all this in JavaScript on the actual device as well. So down here we've got an example it looks pretty similar. It's the same as we did before. We've got a render function, we're creating a React class, but we're actually markup is looking at iOS kind of stuff instead. The idea is you don't have to relearn an entire new paradigm of how to build view components and construct stuff, etc. So that's going to be really awesome. It'll be awesome to see how the Android kit comes out later in the year. So they were 2 really, really sort of simple demos. So I want to show you something a little bit more advanced there. So let's have a look. Okay, right, so I've got Leap Motion over here, and that's hooked into my application. So this application has got hot reloading turned on. So I don't know if anyone's ever played with that, but it's the ability to, because we've got states in behind, So this is our state now. So we've got some active hands up here. It's quite bad, you can't really see it very easily. Hold on. Just gonna make that bigger over there. There we go. So we've got some state sitting in this application. So we've got a master application sitting at the top. We've got some paddles over here. One float left, one float right. And we've got active hands. We've got left paddle Y, right paddle Y. And if I put if it's actually, hopefully this works. Come on. Look at the visualizer. Let's see if it's actually going to pick it up. There we go. That should work. So what I do is I'm going to change the state via the actual JavaScript interface. And then show you how we can actually hot reload things. Come on. Oh, there we go. Right, so this is, I don't know if anyone's played with Leap Motion, but you can do all sorts of fancy things with it. You can hook it into this device, you can plug in all sorts of other things to do with gestures and all sorts of plugins. And the idea is that this is now changed. So I'm trying to illustrate the fact that you're changing state of the application, right? So you can do that. Two hands, you can see the Y positions. So I've got Webpack server running here with hot reloading turned on. So I can do stuff which is pretty awesome now. Let's have a look. So we've got the same application as before. So we've got this massive Java, massive applications at the top there with some initial state that we saw earlier on the end. And we're doing, when the component mounts the DOM, we're actually doing some Leap Motion hook in, try and compute those values. And then you can see here, when we've got a hand entering the scene, we're setting up some states, we're changing the number of active hands, and then we're doing the opposite when we're losing state. And then you can do things like this. So in the render function, you can see, if you notice, the background will actually change colour depending on how many hands I've got in as well. That is all done via just that little call there.
Is that off your laptop camera?
Sorry?
Is that off your laptop's camera?
No, this is off just off the infrared from that.
Sorry, excuse me, it's somebody that's quite new to Java. What is this hot reload you talk about?
So, I'll show you in a second. Sorry, that's all right. So we've got all these components on the screen, and they've all got states underneath, and what I'm doing here is modifying that state. But what if I want to actually change one of the components, now how its properties effectively at runtime on the fly? So I've changed some state here, and you can see that it's changed from its initial state, and now I can go in, I can change something, so I can say, okay, so when there's no hands active, I can change the color. And it's not going to update. It's better if I change the paddle color actually. So let's look at the paddles. So these paddles on the left and right hand side, they've got a color here. Let's change that to something else. Change that to red. Ooh, demo problems. Let's try again. Oh yeah. Thanks. There we go. Right. Let's try that again, shall we? Right. So there we go. And now we can do something else like that. And let's update on the fly back. So what that didn't refresh the screen, if you notice though. It's quite hard to see that because I've got two things on page, but it didn't refresh the screen. It just re-updated the component itself, and I can go in here and do whatever I want and change it around on the fly. So the thing is, I could go to application. I could go to so you can't really see that very well. Sorry. I could go to an application. I can dive down into a certain state within my application, and then I can start messing around with the variables and the views and the styles and everything like that, and see it reloaded live. And you can see that it's kept its state underneath the hood, which is awesome. This is a bit dodgy. Sometimes it doesn't always work. But it is really cool, and it can be a bit of a pain to set up. But if you can get this working, you can actually really save a lot of development time of stopping and restarting all the time. Someone also got this working for Node as well. So this is using the Hot Reloader plugin. Someone's done called a Monkey Reloader plugin, so you can actually do the same on the server as well. So if you change something, it'll swap the server module in as well, so you don't have to restart the server anymore, which is pretty cool as well. That's also a bit dodgy, but it does work. So yeah, that's the. See, sometimes it works, sometimes it doesn't. So there we go. So that's React and hot loading. Obviously, you can do tons more with it, and you can sky's the limit with Webpack. Unfortunately, the documentation is can be a bit sometimes. But I encourage you to look in. As I say, all this is on my GitHub page. You can go in, download it, and play with it as well. You won't be able to do this, obviously, but you can play with the hot reloading. So the other thing we came to talk about is GraphQL. So you might have played with React, but you might not have played with GraphQL because it's really, really new. So as I say, it's in technical preview. It's moving around a lot. So the documentation moves a lot, and if you download the latest version, it breaks quite a lot. But the idea is that GraphQL is a new language to define what a client wants from a server. And Relay is effectively the bridge between the two. So GraphQL is just a language, just a DSL effectively. But Relay makes this magic happen. So it handles the actual React application, asking for things, translating that to the server, bringing it back, and actually flowing that down to the components itself. So once again, let's step back a little bit, look at UI today. Massively simple, but at the base of what most of us do, we're not doing anything more complicated than that. We're doing AJAX calls, we're asking, of course we can have backbone models and stuff that does all this under the hood automatically, of course, but at the end of the day, we're just doing a lot of that. A lot of us might be using WebSockets, stuff like that as well. And then a lot of us are talking to APIs that look very much like that as well. We're looking at something you call users, you get all the users back, you call things in the end, and you get an actual individual user back. This is kind of messy, and you have to make multiple requests as well. So, very rarely do you hit a RESTful endpoint and get all the data you need. You kind of have to make like 4 or 5 round trips to get something you need to actually render your page. Also, if I actually hit an endpoint, I'm probably going to get everything back. Some APIs, we'll probably have filtering on some of them, but not all of them, and it's probably going to be bespoke. So most of the time we're going to get everything back, then we don't need everything as well. And if we change the API here, in a breaking way, all our clients are going to have to update. You might have native and desktop and mobile and all sorts of clients all over the place. You maybe assume you can't even get to some of them very easily. You all have to update at the same time? Well, that's what API versioning is for, of course, but even that's a bit of a messy area because sometimes the version goes in the URL, and sometimes it goes in the header, and everyone's doing it slightly differently. And there's all these bespoke solutions. And every time you look at a new API, it's like, well, I have no idea, I'm going to start again, fresh. So you can't transfer that knowledge across. And of course, the problem with this is the server dictates what we get. We can't tell the server what we want. It just is providing a load of stuff, and that's it. So, does this feel right? Should we, it's 2015, we should be able to have slightly more control over our data flow than this, right? We're using mobile phones, we don't want all the world downloaded. So this is what GraphQL tries to fix. And this is some graphics nick from their presentation, because I can't do things this pretty. Right? So this is kind of where we are. To sort of illustrate the point, this is kind of where we are in flow today. So imagine this being one request to the server. If only it was one request server, it's probably multiple requests to the server coming back. You've composed your promises and you've got all the data you need. Great, happy days. Let's go rendering. So the server come back with a response. Then the top level components gets that information, and however it's done, whatever framework you use, at some method, you're probably manually having to dictate how these things get passed down the tree. In some manner, you're having to do some sort of maintenance, mapping, or metadata or something in order for that to work. Now, what would we like? What would you really like? We'd probably want something like that. So each component knows what it needs. So in this example, there's a Facebook, obviously. It's got a friends list. And then each item in the list. So imagine like the chat thing on the right-hand side, for instance, when you use Chat Messenger. There's a list of friends. There's a friend with a picture and probably a name and whether a mutual friend count, something like that. And maybe that information is encapsulated in friend info. So the list item has like a picture, and then the list the friend info has the name, etc. So forth. Those components know what they want, right? They know what they need. They know they're going to need either the photo at a certain size, or they're going to need the mutual friend count or something like that. They know what data they need. Would it be great if we could compose them automatically up the stack? And so when we first, especially when we first start our app out, the framework knows all the data we're going to need, and it composes that automatically. That'd be great. And it would be also great if we could tell the server what we needed, and it's going to respond with what we needed, and in the structure that we wanted it as well. It doesn't dictate, we dictate the structure and exactly what we want. And then, of course, now we have components that tell us what they need. Now we can have the ability to have a framework that automates passing that data down the tree, because the framework can work out what they need, so it knows what to put back. It can flow that data down automatically. And that's what we'd like. And that's what GraphQL is trying to solve. It's trying to solve this heavy data. It's trying to solve it in a way that we can be more expressive with our data. So the idea is, these are sort of the basic principles of GraphQL and what it's trying to fix. So the data needs a component. The data's needs are an internal requirement. It needs to know when it's displaying. It's pretty obvious, really, if you think about it. Every component data is composable, so everything can just flatten on top of each other. In that way, you can see on the left-hand side, it just flattens down. At the top of the stack, we know exactly what the application is going to need at that point in time. The components' requirements dictate the data structure. So the components, they can also say what data they want, but they should also say how they should look as well. And that would be great. So, two components might need the same data but a completely different way. It'd be great to have that flexibility. And of course, the big thing is mobile, because we want to not only transfer over the wire what we need. Every byte we send, which is wasted, well, it's making our app slow. What's the point? It's just wasted time and effort. And the upshot is the user experience is bad. So that's GraphQL. It's a query language. And it's as simple as that. So top half of this is the actual query language itself, and this is what the result looks like. So this gets embedded into a call to the server. You normally have one endpoint for GraphQL, and you give it, and that server has a bunch of types and things it can respond with. So there's a way to actually ask the server for a schema. So you can do all sorts of things with tools to statically analyze that server and say, okay, these are all available. And then you can also, because we have all this information, that will be embedded in a component. But part of the implementation of GraphQL in React at the moment is that you have to supply it with the server schema. Now we could load that dynamically, or we could give it statically. But that means if we have a schema of the server now, and we have our queries in our components, we can check whether these queries are valid. We can check these against the server schema and say, okay, before we even built our app, we can say, okay, you're trying to reference ID, or trying to reference profile picture that's not there. And it throws an error at build time before you even got the app out, before you've even deployed it. It's great. So some of the things you can do here is, obviously, you could say, I want types. The user at the top level there is a type, effectively. That's a model, and then you're asking for the fields on that model. And then, as you can see, there's another thing there called profile picture, and you can pass things into this. So at the top level, we had user with an ID, and we've passed in an ID number that we want, and it's returned that. And you can do the same thing with a profile picture. You can say, okay, I want the certain size, and it's going to respond with a different size. But you could do two things. You could ask for the profile picture twice with two different queries in it. So I want one at 50 pixels, I want 150 pixels, and it will return both. It'll process that and return it back to you. And those are things you can do. And of course, if you notice, the structure of the request is also exactly the same as the result. So it will match that exactly, so there's no surprises. And you can also do things like aliasing. So if I don't like name, and I want name to be called something else, I can do that with this. I can specify. There's an annotation you can use to say, okay, give me name back as nickname instead. You can do that. So the client's in full control. The great thing about this is the fact that if we want to update something now, we only have to touch one component. So if you go back to our slide a minute on data flow, whereas before, if I wanted to put something new into friend info, and there was some manual mapping going on here, then I'd have to pass that down the tree, down to my lower component. I have to do some work inside my application. I'm probably going to have to go into the server as well and put some new things into the server, so I'm going to have to touch that as well. You end up having to touch a lot of the stack just to maybe add something, and then of course you don't know where else you've modified that as well. So you could be breaking stuff. Your test should tell you, but with this, we don't have to do that. If I update friend info, then that's going to compose up the stack. If friend list needs my piece of information as well, then nothing's going to change. Nothing more is going to get put over the wire. I'm only going to get back what I need, but I'll still get that data passed down to me. So I've only had to touch one component. Now, of course, if you haven't got that information in the server, you're going to have to go into the server and update it, of course. You're going to have to do that. But it means that the amount of components you have to touch to change something is lowered, which means you get less bugs, which means it's quicker, you can keep it mental model in your head easier. And it's nice to work with as well, I think. So, should we do a demo now? Yeah, let's do a demo now. So I'll do a demo for this. This little proof of concept I was working on for something else. It's a little bit dodgy. And I was trying to get Auth2 authentication into it, and it really didn't like that. And I've got issues open on their GitHub profile about how to this thing not working. But let's see if this is going to work. So this is Webpack server, and there's two servers running. There's one for the client and one for the server. So we're running a Node server with a SQL database behind it. So they're standing for both sides of the contract effectively. So, what's my port for this one? I think it's 501. Right, so we have an application. Let's have a look at this. So this should look pretty familiar by now. We've got a slightly more complicated. So the way that you, for the ones that are familiar with React, in order to make a React component queryable, allow it to query stuff, you have to wrap it in a relay component. So you can just wrap things nice and neatly. And this is why you'll see all this kind of stuff composed on top of each other. So if you look at this, so somehow here we've got some festivals magically appearing. And not in that component. Probably that one. So I've got a server with a bunch of festivals on it, and you can actually should be able to look at the data itself. Where's that fragment? Where is it? Query data festivals. So you can see the query data here. So this is what's got passed down. So it's probably more interesting if I show you the actual code. So on the server side, let's look at the server side. Server side is quite simple. We've got some database stuff going on behind the scenes. Don't care about that. This is my GraphQL server. Facebook have given us Express GraphQL plugin, which means it's that simple to plug it into your server. It's ridiculously simple. The complicated bit is supplying it with a schema. So you've got to write a schema to provide to it, and then you've got to map that to your database, or you don't have to map it into a database. You could map it to any source. So you could map it into a RESTful endpoint if you wanted to. So you could have your RESTful endpoint sitting there and then slowly move over to GraphQL if you wanted. So they've thought about this because they want people to pick it up and they want to make it as easy as possible to do so. So this is what a GraphQL schema looks like. It's a bunch of types, a bunch of objects which represent things in your system. So everything here is basically a GraphQL object type. And you supply the fields on that type. You give it names and you give it descriptions. There's things in here to say whether this field is deprecated. So you could actually put something up there and it will come up and say it's deprecated, don't use it. So you can do static analysis on the server and say, okay, I want to read all the types. You can see it in real time. And so that's the type stuff. So very simple, really. It's just saying this name, this type. Then you've got the way of mapping. So all these types basically resolve into this massive document which has a list of queries and a list of mutations. Queries are the things you can query, they're read-only. Mutations are the things you can change. So it gives a set of things that you're able to do. And as you can see from this mutation here, I've got one that says update my festival. So it's got a list of arguments that you can pass in. And you can specify whether these can be null or non-null. And then we're just doing some simple stuff with database. So that all gets passed through to us by GraphQL. And we update our database. So this is the sort of the glue between the GraphQL and whatever your back end is. We don't really care what it is at this point. And the same up here. So we've got festival here. So we can query one festival if we want to. It's of type festival. We can pass in an ID, and we're going to resolve that ID to a database. Same with festivals. It's quite simple, really. But they do keep on changing the spec slightly, which makes it a giant pain in the ass. Especially when it breaks when you update a new version. So that allows us to actually, that exposes the endpoint. Now, let's have a look at the other side of this question. Let's look at some React. So maybe it looks a little bit alien. It's not the prettiest to read, possibly. But this is, so before we saw GraphQL components being passed back pretty much as they were. Now they get wrapped. So in Relay, you can wrap them in a thing, and then you can say what data you're going to need. Now I'm not going to go into the semantics of how this all works and the fragments, etc. and so forth, but the thing we're interested in is down here. So we're saying that we're going to want some festivals, and this is how you do composition. So you're saying, okay, I want some festivals, but also this component up here would like some festival, please. Go and get its information for me. Go and compose that on top of my request. So you can see how it's going to sort of compose down the stack. Go into festival list, same deal here. Except for here, this component needs the ID. This component needs the ID, but only the ID. And it needs many festivals, because this is the list item. And if you go to the very bottom of the stack, you've got name here. So if you see this running in real life, if you look at the actual network request that comes back, there's the GraphQL request going out. And if we get rid of that, the data that comes back is a list of festivals, 3 festivals, and it's got the ID and the name, which is exactly what we asked for. So if we update this now, you can see, so the server can give you, well, no, it's got a load of stuff there we can give you. So what I'm going to do is update this, say I want tags as well. So I'm just touching the bottom component here. I'm not touching anything else, just that bottom component.
Why are the 3 queries in there?
Sorry?
Why are the 3 queries in the root down all the levels? Why does the primary query not satisfy the 3 downstream components?
So it will once everything's composed down. Once it's grabbed all the lower components and it's boiled them up and actually composed on top, that top query will look as the same as all the data requirements for everything underneath it is. But the idea is that you've got everything just composing down on top of each other. It just says, please compose this, please compose this, please compose this. So now I've updated this house as to say I want this component wants to have tags. That will bubble up the stack. So when it asks for the next, when I refresh it, it's going to ask for all the tags as well. So I copy this in. Now, if we refresh this here, we can see the tags on screen. We've only touched one component, remember, and underneath the hood, it's going to ask for those tags. And of course, we could have put anything on that. If we put the capability into the server, we could have filtered them or limited them or do whatever we wanted to. If that capability is there, we can use it. So that's how you use GraphQL. There's tons more under the hood. You can do so much with it. You can put in lots of different types of data, and there's all sorts of things in the spec which I'm not going to go into now, but that is sort of the raw meat and potatoes of it, of querying and how you actually go about putting those requirements onto your React components.
How much about security of protecting the queries, protecting data against getting data you shouldn't be getting from the back end?
Yes, so Facebook have said that what you should ideally do is not hide things, you should just return empty. An empty array or an empty variable or whatever, just an empty string if you don't need it. Not everyone's happy with that, surprisingly enough.
Where's that done?
That's done at the resolve function. So when inside of the actual back end itself, so you'd have to log in, you'd have credentials, of course, as some sort of access level. And then in the back end itself, you'd have to do that in the schema. So you'd have to say that when you're resolving something, say down here, so you're saying, okay, so someone's asking for this ID of this festival. At that point, you'd have to decide whether they're allowed to see that festival or not. I'm actually playing with a version of this that actually uses OAuth 2 and scopes to say, okay, you can and cannot access these things. Other people are going with ways of serving up different schemas. So we've written one schema here, and that's great, but you might want an admin schema and you might want a client schema. Yeah. There's lots of different ways of doing it. Facebook don't really care how you do it, to be honest. And it's all new, and everyone's finding their ground with it. So it's going to be interesting how this plays out. There's all sorts of questions around security that have come up, and people are going about different ways of trying to solve that.
Yeah.
Yep. That was my slide for if it actually works. I was going to make statics because that last one was a bit dodgy before I left it. Okay, so that's all I've got. That's all I've got. I'm Phil Ostler everywhere, pretty much GitHub and Twitter, etc. This, as I said before, everything you've seen is on that GitHub repo. So load it up, play with it. Don't change the version numbers because it'll break, right? But yeah, give it a go and enjoy. Try it.
Questions?
Mm-hmm.
Yeah.
There was a file that you brought up where you had an app relay annotation. Like some kind of
Yeah.
what was
So
that?
that one there.
Yeah, what is that bit doing? I haven't seen that before.
So there's a limitation in. There's another issue. Ooh. Late starters.
Sorry about that.
It's all right. So there's a bit of a. This allows you to say I want more than one effectively. So the design of GraphQL is such that it expects an ID ideally, and the way the system, the flow through GraphQL and Relay always expects an ID effectively. This is an annotation that allows you to say I want more than one effectively. There's also these other annotations you can put in here to say I want a list. This is going to be a list.
Yeah.
The reason that we've got things like this, and it looks a bit weird, is because Facebook have used this for years, and they've basically distilled out, the generic bits of their system, and it works for them quite well, but it might not work for everyone.
Yeah.
So, it is good, and you can do a lot with it, but it is, it might. There's limitations in there. Things like, so at the very top level, when you're actually querying for something, you have to say, I'm looking for a certain type. So as we saw before, you're looking for a festival, for instance. You can't, at the very top level, ask for a list of festivals, which is quite annoying as well. So that's another limitation that's just come in because of the way they use it and the way it's been built within Facebook. That is a pain to find the documentation as well.
Yeah, I've used Relay, but anytime I've had like multiple items, I've used their connections interface.
Yep.
So I haven't seen it before. So I'm assuming you do that when you're not using connections.
Yep.
Okay, cool.
Yeah, well, as you say, you can abuse this in other ways as well.
Yeah. It's all abuse.
It is pretty much, yeah. Anything else? Yep.
So now that you can sort of ask for any data back, we've kind of thrown cacheability out the window. Is there any clever ways around that? Or?
Another very good question. Only not at the front end level, no, not at the moment. Not that I know of. If you read the documentation, their suggestion is you try and cache as much as you can behind the interface, not in front.
Right.
So if you were, for instance, hitting a RESTful endpoint, you would cache that up. It's a bit of a problem. You can make a GET request to GraphQL, which is more cacheable than the alternative, which is a POST request. It's not something they've really tackled. They're leaving that open to the community to try and give an answer to it. So this is a great thing, though. If you if you see something, go, okay, can't do that. How are we going to fix that? You can jump on board, and they're pretty open. So, yeah.
You're doing a post. I'm just wondering if you could cache it even with post, because you could put an ID on your tag that is your request, and that was your particular type of request.
Yeah.
Then the server would then know. Then it could cache it because it would say that ID is that. So you could do something like every type of request that you make, give it a certain tag type, and then it would cache. You could just have to get and a post and say, put like a query on get to it. The server doesn't do anything with, but your CDN would go, that's that, so I'll return that to you.
Mm.
To make them each unique.
So the problem comes is when you start doing, if you've just got one client making a request for one thing, one set of requests, that's pretty easy to do, but you might have multiple clients making multiple different dynamic queries all over the place.
You're better off doing it, putting your CDN on the back end, strange as it might seem, actually just writing your own in the cache and just saying, this request, have I done this recently?
Yeah.
That's the question about caching.
Yeah.
Yeah, because Relay will cache all of your
I'm more thinking about sort of user browsers when you want to have your data source as close as possible to the user. So this means you have to go to server.
Well, I think Relay doesn't have offline modes.
Sorry?
Relay doesn't have offline modes.
No, not at the moment.
But,
No.
it's essentially just a store for the nodes that you're getting back from the server. So you'd be able to put that into local storage and repopulate that on a page refresh, and then it would be able to continue where it left off. So then it would only be fetching new stuff which it hadn't already fetched previously on previous page heads.
Besides which, I suspect the components themselves could decide they didn't really need an update right now and not bother adding themselves to the query, couldn't they?
You could do. There's so many different ways you can go about doing this. This is the great thing. There's no like. So Facebook have deliberately not said this is the way to do things. So you could abuse this and do whatever you need to do for your stack. Yeah. Rubbish answer, but there's no actual answer to it. So.
Wasn't sure about the server data model. Does it require that the model you're asking for be an arborescence, or does it support arbitrary graphs? So I assume if you've got type A referencing a collection of B, B can reference a collection of A as well, and you can query it in your root, yeah?
Yes. So yeah, you can do, yeah.
What server languages they use? Just Node at the moment, or is there any others?
So the reference implementation is in JS.
Right.
There is a Ruby one as well that's been built.
I'm not a fan of Ruby as well. It's all right.
I do Ruby as well. So.
Yeah, no, server side I don't. It's fine for doing stuff client side, that's right.
There is, yeah. So there's a Ruby one. But actually, that's coming on quite nicely as well. Sorry. So the Ruby one, they actually built a lot of that from the little snippets from before they actually released. They tried to preempt what it might look like and actually did a lot of work beforehand. And they actually did quite a good job. So yeah, there's a Ruby one, and I'm hoping there might be one in Go at some point. That'd be pretty awesome. Yeah, I've not seen anything yet. I've heard talk of it, but certainly nothing concrete at the moment.
You could just have your stuff in Node, and then just use that as a gateway to everything else. Because I know eBay do that with their JS stuff, and they shifted all the front end stuff to Node, and then shifted all they left everything back end in Java.
Yes, effectively use it as a proxy.
Yeah. So they put all the gooey, sexy stuff in JavaScript and front end, so they could get the transformation. That's what they were doing. So they were transforming it into their back end stuff. So they cleared the whole back end, and the front end wouldn't change. So that's probably the better way.
It's a pretty better way to do it. And it's just creating an abstraction layer, isn't it, between the two? So yeah, win-win really.
I think we'll wrap it up there, but I'm sure Phil will stick around to answer any more questions. But thank you very much.
Give it a go and see if I
Here
can.
we go, yeah. See you around.
Just in case you missed it earlier, we will give some beers down at the Hawks after this. There is pizza. Enjoy it. Your beers, if you wouldn't